Hello students, it's Dr. Sansom, and today we're going to talk about heat and work. So the reason we're talking about these is because heat and work are two ways that energy can flow into or out of a system. And so if I want to know what the change in energy is of the system, then it's helpful for me to understand what's happening with heat and work. So heat is a way of, when we use the word heat, it's important to remember that heat isn't something that the system possesses. Heat only refers to the transfer of thermal energy, either from the system to the surroundings or from the surroundings to the system. So heat has the symbol Q. And Q can be positive if heat is added to the system. Another way to say that is that heat is absorbed by the system. Because the energy of the system is increasing, the sign of our Q will be positive. We can also have a negative heat, and that means that heat is removed from the system. Or another way to think about that is that it's released. We also have other words that we use for this. When heat is absorbed, we call that endothermic, because heat, that's the thermic part, is going in, that's the endo. And if heat is released, then we call that exothermic, because heat is leaving the system. Okay, we also have work, and work has the symbol W, very convenient. And work can be positive when work is done on the system. And in this class, we're just going to worry about pressure volume work. And so work being done on the system happens when the surroundings, I can do it, the surroundings push, that's the work, on the system. So in other words, that's when compression happens. We have negative work when work is done by the system, which in other words means that the system pushes on the surroundings. And another way to say that is that it's expanding. So we have these sign conventions for heat and work. The reason we have the sign conventions is because our goal is to determine what's happening to the internal energy of the system. And heat and work are two ways that energy can be added to or removed from the system. We get positive heat and positive work if energy is getting added to the system, and negative heat and negative work if energy is getting taken away from the system. So when we add these together, then we get the change in energy of the system. Let's do a little practice problem here. I would like to know if I have a system that is doing work on the surroundings. And also losing heat to the surroundings. If this is true, do I have positive Q, positive W, positive Q, negative W, negative Q, positive W, or negative Q, negative W? Okay. The first thing they tell me is that the system is doing work on the surroundings. So that means the system is pushing on the surroundings. Pushing takes work away from the system. It has to exert energy in order to do that. So that means my work will be negative. So I'm going to eliminate choice 1 and 3 because my work should be negative. And then they tell me the system is also losing heat to the surroundings. If I'm losing heat to the surroundings, that means heat is leaving the system and therefore energy is leaving the system. So I'm going to have a minus Q and a minus W. Okay, let's do a practice problem. So we want to know what's the energy change of the system when we have a combustion reaction. That already tells us something because whenever a combustion reaction happens, it's going to release heat. It transfers 32.146 kilojoules of heat to the surroundings. While the piston expands from 1.465 liters to 3.687 liters against a pressure of 3.64 atmospheres. Okay, so they've given me some information here about heat and they've given me some information about work. What I'm going to do is think about those two things separately, and then we're going to add them together to get our total delta E. So the first thing is they told me about Q, and they were pretty straightforward here. They said that 32.146 kilojoules of heat is transferred to the surroundings, meaning it's leaving the system. So that's going to be negative 32.146 kilojoules. And for work, our equation for work is negative P external times delta V. So I'll have negative 3.64 atmospheres. And then I'll need my final 3.687 liters minus initial 1.465 liters. This number is going to be in liter atmospheres when I'm done, and so I'm also going to convert from liter atmospheres into joules. 1 liter atmosphere is the same as 101.3 joules. Okay, when I calculate this out, I'm going to get for my work negative 818.2 joules for work. So now if I need my delta E, I'm just going to add together my Q and my W. That's negative, and I'll turn this into joules, 32,146 joules. And then plus negative 818.2 joules. My equation says plus, but the sign of the work is negative. So in the end, I'm going to subtract that. But I need to keep track of those signs really carefully. When I add these together, I find out that my delta E in total is going to be negative 32,964 joules, or negative 32.964 kilojoules. So that's an example of how we do this delta E with heat and work. I hope that's helpful, and I hope you have a great day.